Hi everyone, my name is Erik Odland. I'm heading sales and marketing in Grieg Connect. I'll share my screens with you and a little bit on our innovation activity. Grieg Connect is a supplier port management system, but also terminal operating systems. We have around 80 ports and terminals as clients. We're owned by the Grieg Group in Bergen. 3 topics today. I'll talk you through 3 steps that we see you need to take towards the future of ports. And I'll show you 1 slide on our port management system. And I'll talk about one of our innovation projects, Digital Port Assets. It's a map platform. We see that the ports need to get connected, moving away from kind of analog paper pen and even moving away from Excel spreadsheets and digitize your activity. That's kind of step number 1. Second step is learning from the consumer industry, becoming more self-serviced. The best example is the banking industry, which used to have over-counter service, which today is mobile banking. So it needs to be the same way in the port. And the third step is not an autonomous port, but it's like a data-driven port. The data will help you make decisions, but data will also kind of do decisions for you. The system will actually, based on real-time data and historical data, optimize your operation by making decisions for you. So these are the 3 steps that we see. This is our port management system. It's a snapshot from the Port of Bergen, which is quite a busy port. At the moment, they've got 58 vessels in the port. Port of Bergen has around 100,000 port calls every year. So we need to have quite an efficient routine catching all those calls using AIS data and our geofencing algorithms. And then automatically invoicing each call with the related services. On the right is just a snapshot of our mobile application that is in use in the port of Båtsfjord, really far up north. And it's a self-service app, meaning the captain or the vessel has access to the shore power through an app, and they can start and stop the shore power system. They can choose outlet, choose voltage, and it's a 2-way communication with the power system, so they can choose frequency and hertz, and they can choose amps for the power. So basically, the port in this case, they just monitor the fuel power consumption and automatically invoicing, and the vessel is self-served. Then about port asset, which is kind of a main topic. This will find its way into the port management system, but it's a recent launch we've had. It's a combination of Norwegian Mapping Authority and 3 ports, the Port of Oslo, Bodø and Tromsø, and Grieg Connect. It was starting point that the Norwegian Mapping Authority, they scanned, in this case, 18 ports. So I'll show you a little bit from the scanning. I'll just fast forward here. This is mobile mapping. There's 2 ways of scanning in this project. It's this mobile mapping, but it's also normal surveying and measuring all the port objects. You will shortly see here that some of the objects that's measured in this case, it's ladders, fenders, power outlets. Moving on, here we have a little bit more. It's the bullards, which is a key element in our projects, getting all the bullards correct. And the last part in this video, key front and key front area. Oh, what did we do with this data? Sorry about the crowded slide. To the left is our projects with the port. To the right is the national initiative from the Norwegian Mapping Authority. And what they did was they did the mapping, but they also did one more thing. And that was they made a standardized instruction for measuring port objects, which we followed. And they have a national service where all the data eventually ended up. In our end, we made the map platform, but we also made a database for orchestration, all the master data, all the port objects. The map was for communication and data sharing in the port. So the port wanted to kind of keep control over their objects, but also wanted to share it because they found it's really open data anyway. In this case, there's a two-way synchronization of data to the national service, but also back and forth. So typically all the data registered in the port will be open in the national service, and then you can use that data to build innovation. So the new digital pilot service is going to use these data. The port, they wanted this data to use them for building operational applications. I'll show you one application. This is the kind of the tool. You got your layers, your key fronts, your live vessels, everything is switch on and off. You got your workspace. You can see the bullards here. It's the Port of Oslo. And then you can click on one bullard and you can edit kind of all the metadata on that object. And it automatically synchronizes to the national service. So it's also kind of a national maritime infrastructure in Norway here. So one use case that I'll talk about is autonomous operation. We're working with MacGregor, who has robotic cranes for autonomous vessel cranes. And in this case, the use case is that there's a vessel that calls a small port late at night. It's got the crane on board. And that means there's no need for an operator. The vessel is able to typically discharge or load a number of containers, in this case 5 to 10 containers, put them on the quayside, and there's no personnel working overtime. Nobody on the shore side, nobody on the crane operation, and the vessel, this is important, can have a 24/7 window of operation. They can have a safe cargo operation, and when they're finished discharging, they can sail, because that's when they make money, when they sail. So this means that the objective was, in this case, to increase the flexibility and competitiveness for this short sea cargo operation. So it can even be kind of good business with low cargo volume and small port operations. So the challenge in MacGregor's case that they had no information on the key area. They didn't have accurate data for where to put the cargo, and the robot crane needed to communicate with a digital port, which they didn't have, which we then, as I've showed you, we had in the port asset project. We could provide the crane with a coordination system and the key area for where to put the containers. We even connected our yard planner here in the terminal operating system, or where we are connecting it now. So this is the future of autonomous operations, where the kind of the systems talk to a digital port. This is kind of a picture of how it works. Down to the left is the crane with the machine vision here, and kind of getting the near field insight of how the key front area looks like and where of the containers is information coming from us. And in the background is the port asset tool where all the data is stored for the port. Good. If you would like to know more about port assets, port management, our terminal operating system, we've got a very exciting ETA prediction algorithm based on machine learning, So please, I'll be happy if you contacted me. My email address down there. So just want to say thank you all for kind of a brief introduction to some of our innovation.